It's much safer and easier and even less expensive to buy glass from a company like Spectrum that's making it just for glass blowing. And so that's what all the guys do now. And there are two major companies that make glass. One is on the West Coast, Spectrum, the other is on the East Coast, and that's, what is that? Spruce Pine, I'm just joking, North Carolina makes some glass. So we luckily get to use this now. It's safer. I don't have to breathe as much dust.
Is this all clear glass?
That's a ton that just came in of this.
Clear glass.
Yeah.
And then you
This
color.
right here.
Yes.
Okay.
That's
And
what's
now-
in each of those bags.
Okay.
What you're seeing here are, these are all colors. These colors are mostly from Germany. Some are from Portland, Oregon. They actually are in these big buckets over here. So we can take the clear glass, and you'll see what these guys do today is we're picking up a cup and putting some color on the rim. So if we want colors like this, that purple, the aqua, and the green, and so forth, that's on these pieces, we just pick up some of this color in the pan, and that coats the glass. Now,
It makes it look like the whole piece of glass is colored,
Yeah.
but actually, if you were to break it
Just
and look
colored
at
on the
it, that's supposed to
outside.
break it. But if you were to get a cross section of it somehow
It'd be clear on the
miraculously, you'd
inside.
see that it's 95% clear and only 5% color on the very, very
Interesting. Okay.
either inside or outside or sometimes a sandwich. But glass has this property that refracts whatever the color is that's near it to make it look like the whole piece is colored.
then, so we can pick it up in the powder or chip form, or we could take a piece off of this rod, heat it up in that oven just like they will be doing soon, pick it up and put either the first bubble with this color, so it would be with the clear, it would be red. In this case we have, this would be a light purple, okay? So we can work with these solid rods as well. So
It's a very concentrated color. I always say it's a little bit like Kool-Aid. You just add water to the two quarts of water to the little package of Kool-Aid, and it gets you that whole drink. But if you want to
we have this, so we put this in that small ceramic oven upside down, and they'll pick that up here, reheat it, dip it in the blue glass that's down here, put a color rim on it, and then put it away. Now they have to pick, it can fall off very easily, and they were teasing me earlier, I didn't really clean them off, so they're a little dusty, so they lost one.
Oh, that was your fault, huh?
Yeah, come on this way. That rim is actually blue, it looks red because it's red hot. This glory hole is 2200 degrees, 2100 degrees Fahrenheit. So if he doesn't pay attention, that'll fall off. He's got to make sure, okay, they're going to knock it off. He's going to walk right in here. Okay. And in a studio, you never move fast, you always move slowly. You'll walk around out here. You're used to having people around you. So actually a punchy rod. So they have to be hot or they will not adhere to the glass. Now see, you'll fire polish the bottom. So take that little, smooth it out. And then he's going to put it back in the oven, which will anneal the glass.
He's going to back up. Sorry.
Where's it going?
I think he's going to go back over here, so I'm just backing up.
So that glass, that temperature was
So he's got a little bit of hot glass on the end of that solid steel rod. We call it a punty. That's a word that should go into your vocabulary. Punty. P-U-N-T-Y. Punty. Punty. But that's exactly what they would do. They would make the big ball, and they pull the neck up, they pull the tail out, they put the little parts on it, you know, the face and so on, and then so all glass that we make here has to be annealed. Annealing is another word that you want to put in your vocabulary. Annealing is the, does anybody know what annealing is?
Yeah, it cools it gradually, right?
Cools it gradually, and what happens during that gradual cool, as opposed to if we just put it on the floor, it would explode. We know that.
Yeah, yeah.
It's almost like temper, except it's the opposite. Temper, which you know from metalworking experience, or maybe you have friends that temper metal. Temper is putting stress in to make it stronger, which works great for metal. Annealing is taking stress out. And that's what removes the potential of it cracking. If you just put it on the floor, it would crack. But by gradually cooling very, very slowly, the difference in temperature of any part of that piece of glass is not much different than any other part of that piece of glass. And therefore, the cooling, which always is accompanied by a shrinking process, does not put too much stress in the glass if you anneal it correctly. So annealing is getting the stress out. And some people will use the word temper, and you want to gently and politely correct them.
Bubbles in here, so in order to, the glass, we work our total life getting bubbles out of it. And then we get customers say, well, would you put bubbles in it for us? So a really easy way is to take baking soda and put maybe a cup of baking soda in 5 gallons of water. And then when the glass is really hot, the first bubble, you dip in there, put your coat of that on there, you just dip in very briefly, come out, put the next layer of glass over and the bubbles up there.
We being the contemporary American glass blower types. Almost all of it is made of a series of layers. And this is true of ancient glass as well as modern glass. It's made up of a series of layers. When you try to gather the glass out of the furnace, it's so runny, it's so unviscous that you can only get a little bit of it. It's like honey on a knife. And if you try to wind too much honey on the knife, you know what happens? It all goes back down in the honey jar. That's what happens with glass. If we try to get too much, you can't do it. So you get a little, bring it out, let it cool down, then you go back and get more. And then cool that down and go back and get more until you have the amount of glass that you need to make the object. For instance, this would take usually one, well, if you were making just this, it would be 1 or 2 gallons. To make the chicken, you might have 3 gallons, maybe even 4. And then other pieces, big pieces, you could have as many as 5 or 6 layers. One over the other, over the other, over the other. And one of the neat things about glass is that you can trap interesting imagery between the layers. And everybody looks at it and they say, wow, how'd they get that bee inside the glass? Well, but now you know the answer. The answer is they didn't. They put it on the outside and then they put more glass over it. It's that simple. A lot of our tricks, which we don't tell everybody, you have to realize this is a very special group.
So in this case, there's 3 different colors of glass. Started with the orange, put amber, and then the ruby dots, and then clear. You can just see the rim went over the top of all of that color to get this. In this case, you started with clear, went into white, picked up black, put more clear over the top to get the chicken. So this we started with clear, then amber, and then some dots inside, and then more clear, and then some silver on the outside. So depending on the combinations of what we want to do, we layer the glass. As Fred said, we can put imagery inside. You can get more and more complex with what you do for chemistry and so forth. Many artists will have Billy Morris and put all kinds of imagery in glass. Some of them take hours to do, or prepared days before, laid out, picked up hot. And those nuggets. And then add color either in the powder form, chip form, or the solid rod. So that's the basic way. And when we're working, this is called the glory hole, that's called the glory hole, they're both on. So it's nice and toasty. It gets warmer in here when everything's up temperature. That's what we call medium-sized glory hole. Behind the sheet is a very large glory hole, 3 feet wide and 24 inches wide, so we can make really large pieces. So we can put it in, and the glory holes heat up in one day. The furnace, once it's on, it stays on for a year. That pot lasted for a year and then finally wore out. And I was pushing it to the end because I wanted to get as much as I could out of it. And we had it up for one day when it cold broke through, so we had to turn it off. And there's a new pot at around 900 degrees coming up. So we'll be able to use that this coming Thursday. We were hoping to have that already, but it's probably the Seahawks game that was the problem. For sure. So if you want it super thin, let's say you want like a net form, that's done with a torch. So there's torch working. You work with Pyrex, which is actually borosilicate glass. It's very forgiving, but you use a torch and rod, and you can build sculptures that way. And there's a Czech artist that makes huge pieces that way that fill a gallon. Normally the way we blow, or Fritz blows, or Billy Morris, or Chihuly, it's all what we call offhand blows glass like this. And the other word, torch or flame work, you'll hear quite often. So it's quite different, but it's we make incredible.
About the 1880s, 1890s, and it was the factories that were making cut glass, like your grandmother has a collection of it, cut glass. And so there were companies that made that glass, cut that glass. Libby Glass Company in Toledo, Ohio, made the glass and then also had cutters that cut the glass. Hawks Glass Company in Corning, New York, did not make glass. They did not fabricate glass, Hawk, but they cut it. So they would have their blanks made in some other factory like Corning. Okay, we're coming through here.
Girls, all the way.
So, interestingly enough, you know Steuben, they're no longer in business. You know Waterford, no longer in business, went to China. Why? Lead crystal is clear, and after a while, it's boring. Color. In fact, I remember when I first started making glass, I was going, well, why would you want to work with just clear glass? Why not color? And I asked my friends from Sweden, Bertil Wallin, I said, well, why don't you guys make more color? He said, it doesn't sell. And I said, I don't know, I think in the United States, color glass is going to do pretty well. And he said, I've designed glass that's colored 15 years ago, and the factory won't do it because they're hung up with color because it's selling. And so they just began to switch in the 80s to some color pieces, but many of those factories have gone down because they didn't get on. Young Americans are using color, doing well, and color is kind of where it's at this point century. However, now, having worked with glass as long as I have, I'm now very interested in clear glass again. Chris is doing cutting it because that's a whole new world, different way.
New to us.
Yeah.
It's an old world that's new to us.
So
I've seen them blow.
the question was, is this similar to Murano? Yes. Offhand blowing, and usually what you'll see in Murano. However, in Murano, some of the best torch workers in the world are on the island of Murano making glass with torches. But they're also mainly known for their offhand blowing the way we do it. So they work both ways. I own some glass from a fellow named Cesare Rossi, who's a really good torch worker on the island of Murano. But I have some glass in here by Davide Fuin, who's probably the finest goblet maker in Murano today. One of the few masters left in Italy. He says there's no Italian masters coming up. They're all coming up in America. So that's a big change. For young Americans, many of them, I don't even know their names anymore. We used to know all of the guys almost personally. Now there are thousands of glass blowers. When I was working in Seattle in the 60s, there were 3 of us trying to make glass there. There are over 100 studios in Seattle right now. So things have changed a lot. And Murano used to have 250 factories. To date, I'm not sure. I think it's under 50 factories, probably less than that now in Murano.
If you wanted to work in cast glass, can you work in this kind of an oven?
You can. There are several ways to cast glass. I have some sand boxes, and you can do imprints in sand, make molds out of sand, and pour the glass in, and you can cast it that way. You can have a kiln like this, and you can make a mold, a plaster mold, and you can then have a system where the glass, it's called cullet, you heat it up and it pours into the mold in that oven. So that's another way of casting the glass. Another way is an open mold, face mold in a very hot oven that you actually pour the glass into the mold, close the oven on it, and then anneal it for several days if it's very thick. So there's what they call chunk de verre, pot de verre, which is using very fine chips to make a vessel with molds. So yeah, there are all different ways to cast glass. You can cast glass into simply a metal mold. Paul Marioni was pretty famous for casting into metal molds and sand molds and doing architectural pieces, very large walls or windows. So there are many kids that blow glass, and they'll cast something in sand and pick it up on their blowpipe and blow a vessel with maybe hands on the side or some sort of imagery on the side. So you might see that. So they use a combination of cast and blown to achieve it. So yeah, there's, you can also take glass and fuse or slump it. So in an oven like that, you prepare all your glass outside. A local guy, Richard DeLon, does some beautiful pieces. He's done very large commissions for schools where he literally paints on the glass with chips, fuses those several layers, and then slumps them into molds and shapes, or just has them flat as an image. So that's another way of working with glass. There are young people now taking cane, strips of glass, putting them into an oven like that, bringing out the plate, heating them up, taking blown, and then picking those up, and they call those roll-ups. So these are fuser slumper people, as we call them. We call them warm glass instead of hot glass. Warm glass people are marrying their warm glass techniques with hot glass techniques and making vessels. So there's several different ways to achieve artwork in glass. So fusing, slumping, torch work, offhand, casting, and it's a very large field. And there are young guys coming up with new stuff all the time. One thing that we did in the Pike Place Market, I had a business there years ago, is we had a studio on Post Alley. I don't know if you've ever been in the Pike Place Market, but the drunkards used to leave bottles, wine bottles, at our doorstep. And one of the guys working with me, Charlie Perry, said, we ought to do something with those. So we picked them up, reheated them like this. First we put either painted imagery on them or sandblasted imagery, and then picked them up and took the wine bottle and made a vase out of it, just for the fun of it. And we did a series of those for a while. So you can do, it's like this, recycling glass that you make something else out of it and actually make a drinking glass this way and not throw it away.
What temperature would you melt a bottle? What temperature? If you have a regular kiln at home?
So you mean just bottle glass by itself?
Yeah.
You've got to get up to 2,000 degrees.
2,000?
Yeah, to melt it.
Oh, what?
22
What color
to
would
actually,
that be?
when I owned a factory called the Glass Eye, we used to buy 5 tons a month of glass from Northwestern Glass, which were jars crushed up. We would add a flux to them if you just picked up that glass, it would be so stiff you had to run from the curb to the bench. By the time you got to the bench, it was too stiff to move. So then we put soda ash in there to flux the glass and give us a longer working time. So we could then walk to the bench and open it up. So you could use bottle glass. It should be all from the same company. Window glass. Use color for someone like me that I don't, I've got too much glass, too many different colors. It could be recycled and used again, but since we want specific colors, it doesn't pay me to use it. It's too expensive. So there are many ways, but yes, you could do that. You could use, let's say you collected one wine bottle from one company. Collect that, crush it up. And
Well, I don't know temperatures, but I know cones. My kiln fire is at cone 6, which is low fire.
Yeah, that's.
Wouldn't do it?
You want to
It
get
would bend, but it wouldn't be
would
molten.
wouldn't be molten.
But it would bend.
Okay. I'd have a lot of fun with it.
Yes. At 900 degrees, there's no color. But I'm going to open it up. This is an electromelt furnace. So there are electrodes that go down like this. Inside. So I'll open it up real quick. And there's 50 pounds of this cullet sitting in there like a mountain right now. Now it won't melt until it gets up. Its melting temperature for this glass is 2,250 degrees. So it'll start to flatten out probably around 1600 it'll start to slump. 1900 it'll slump a little more. 2000 it might start to really get hot. Once it gets to 2200 it would flatten out. In 4 hours at 2250 degrees, if I had it full, it would be a totally hot pot the next morning. So it'd take 12 hours to get molten. Really hot. There are many glass stores that rent studio time. So it depends on. You definitely have to know what they're doing. In the beginning, they rent the studio to get an idea of how much glass they're using. In a normal day, when you're young, you don't use very much glass because you drop a lot of it on the floor. As you get more proficient and the larger your team is, it's not uncommon for us to have 5 or 6 of us working on a piece. So we're starting a piece over here and finishing a piece here. So we're efficiently using time, but we're using more glass, but we're getting more done in one day. We want to fill up. These are called annealing ovens. Everything we make has to go in there, sit at 950 degrees, and then come down over to room temperature overnight. Once that's on, we want to fill it. So to fill it, we've got to work pretty hard. Every night, let's say I use half the pot. Well, instead of letting it go all the way down that day, that night I'll throw glass back in it and fill it up and melt it overnight. So the next day we can work again. Now some days we'll be using all of the pot. And that, instead of working 3 hours after work to fill it, we'll work until 10 o'clock at night filling it up. And then it'll be ready the next morning. So some days I'm charging 150 pounds of glass. Some days I'm charging 200 pounds. Charging means throwing in the glass. You can only put in about 10 scoops of this glass per hour. So it might take 3 to 5 hours to fill it up again.
You purchase these cubes?
Pardon?
You purchase these?
Yes. The bags out here are full of it. You see outside the door. They're from Spectrum Glass Company. I buy a ton at a time. We went through, a ton a month. So 12 tons last year. So it's about $1,800 a ton. So we spent a lot on just glass. I have 2 1,000-gallon tanks. And those usually cost about $2,500 to fill up. I go through those in 1 month.
Wow.
Electrical bill is about $2,500. So you got $2,500, $2,000. That's $6,000 right there, not counting the color. And the boys get paid. So it's a lot of money.
Yeah.
So we have to do some shows, get off the island, sell glass, just to keep it rolling. It's always it's a balance. But I wanted to have solid, so I did a series of pieces. We did some blue and an unusual pink and purple, various colors a while back. We haven't had time to do some lately, but that's an example of solid color through. And when you look at glass, you can't tell that there's just a thin layer. And but that's just to show you can work with solid. And if you look closely, there's actually, my goddaughter played with the glass and put little circles and designs. They're very hard to read. But and then she put zigzags in this. And she was just having fun doing it. I think she was about 10 years old when she did that. So throughout here, there are all different kinds of ways of getting patterns or techniques in the glass. This is called encomo. These are two bubbles that are fused together, so we have glass blowers at the two separate benches working at the same time, and then we bring the pieces together, and so you can do patterns like this. This is silver put on the outside of the first bubble to get the pattern of the lotus leaf. Again, my wife designed that one. So, and then of course pumpkins are probably one of the most favorite things in America now. I think it's kind of funny. And every studio in the country makes them. Although it's kind of like rice and tea for some people, but I can't imagine. I've had customers on Whidbey say they've fallen 12 with my pumpkin.
How long has it been popular, the pumpkin?
Pumpkin started selling really well, I think, in the 2000s. There were some big, we made them in 1979, 78, and so in the Pike Place market, because there was a competition for pumpkins there, they were all real pumpkins. So we thought, well, we'll enter it, and we won the contest with a pumpkin. Actually, Sonia Bloomdahl made the pumpkin, and then I cut the eyes out cold, and that won the contest just 1 year down there. And then, and some of the farmers weren't too happy about it because they were flies. Cheated. So pumpkins have been made a lot. I know there's a studio in San Jose or California that does a big pumpkin sale, and I've heard they sell as many as $40,000 worth of pumpkins to support the school program. And there's one company in Tacoma now, and that's all they make are pumpkins.
So I took what was the horse barn and turned it into my shop. And I've had this dream that I wanted to have a studio to do the cold working that I'm interested in today. Now I start with hot glass originally and make something, an object. Could be a bowl, it could be a goblet, it could be anything. Could be a blob, could be a turkey. And then I carve into that to get the decoration. But this is a new, relatively new direction for me. Divide it in half and have a working area to the left and a display and clean area to the right. So, dirty side, the working side. Just normal tools and maintenance and so on down here. And then from about this point on, all the way down there, is all equipment for doing the carving and cutting of the glass. Green one and the blue one. And as I said, a lot of what I'm doing is similar to what our grandmothers collected, that cut glass business that they collected. These are stones. You pass.
As are these?
As are all of those, yeah. And they have a lead center
Different
with
grits.
threads on them.
Different grits.
And they're all different grits and different compositions so that they make a slightly different mark. And I have to learn what those marks can be, what they are and what it does. So I do these kind of random, just trying them out.
So did you make these glasses?
Yeah, those are just drinking glasses.
And then you
And then I just,
played?
yeah, it wasn't a glass that I was so in love with that I couldn't destroy it if I wanted to.
No, but you went over there and made the glass?
I sometimes work
In
over there
Dreisbach.
and then bring it here. Yeah.
Where else do you make glass then?
Oh, all over the various studios around the country. I don't have a hot shop, so when I want to blow glass, I have to find a place where I can rent
Oh, thank you.
time to blow.
Oh,
So, let's see. This shows you the variety of the cuts. When I'm roughing it in, it's very chalky looking. And then I can bring that all up to a more of a polished look. I could actually go all the way to full polish, but I generally stop at this, what I call the satin look, because I can see it better, see the shapes better.
That's so pretty. Would you pass that glass around, your test glass?
Thank you. Did you guys see it? Boy, my parents, we lived in Akron, Ohio, and my parents were both teachers, and so all my two brothers and I, and my parents and I, we had Christmas vacation together, 2 weeks, and my mother loved the sun, so we often went to Florida. And while I was there, I fell in love with alligators.
okay.
That's the short version.
That's just water?
Yes, it's a lubricant. And it also chills, keeps it from cracking. So, watching somebody engrave glass is a little bit like watching clothes dry.
But you're cuter than the clothesline.
This is, thank you. This is the mark I just made right here. That,
Okay.
yeah, just pass it around,
Okay.
point that mark out to everybody.
So you take somebody's jars or
Well, I
vessels?
blew that one, but I also take other people's sometimes.
That's what I was wondering.
But any of them, I do those other people more or less as practice. I don't do those as my product. If it's gonna be something that I'm designing and feel proud of, then I make the glass first and then I cut it. Did everybody see a piece of glass?
Now, in general, when you do this, well, this is pretty thin. It doesn't have to be real
That's what I was
thick.
wondering also.
You know, I mean, is there?
Well, what you have to do is make the cuts shallower than the thickness of the glass, where you get
Pieces.
a hole. Yeah.
That's what they
Have you
call it,
shattered?
colander.
Slippery behind.
That's pretty tough, isn't it?
And this is a real good example of a screw up.
Oh, my goodness.
And it was after a lot
Of
of work.
Oh, wow.
And then I finally busted through.
You ever had a piece shatter while you're working?
No, fortunately. I am pretty careful to not get it too hot, which would make it crack. I have cracked a couple of pieces because they got too hot. You pass that guy around with the hole in it.
And too hot, meaning forget to add more water.
Didn't have enough water.
Yeah.
No.
Okay.
No, misjudged. Oh, I'll just do a little bit more. Wrong.
You meant to do these little openings at the top.
Oh, I would have finished that up, yeah. Grinding and polishing business, which we call cold working. I grew up with the blown stuff.
Did you do this?
All of it, everything in this building is mine.
Oh, Mary, that looks like you. It does. Mary does very whimsical
Ah, cool.
features.
Well,
I
would
do
you
too.
all like to chip in?
Make him an offer.
So that, for instance, that's a good
You just need a ballpoint pen.
That's a good example of the kind of work that I did before I got interested in grinding. And the grinding thing happened because of a commission that I received from the Corning Museum of Glass in 1992, 93. 92 they asked me, 93 I did it. They wanted a big chalice that was a commemorative chalice to celebrate the 30 years of the glass activity that we're all a part of. I'm hoping all of you will come to my lecture when I come up there next month.
Oh, yeah.
And the title of my talk is Where Were You in '62? And the reason for that title is that in 1962 there was a workshop at the Toledo Museum of Art in Ohio that was taught by Littleton and Labino and some other people, and that's where we finger the start of this activity that we're all a part of today. Now before '62 there were factories, but there were not independent artists blowing glass in their own personal studios. That didn't exist. Pardon?
For the sake of art, rather than.
Just making art, yeah, yeah. It could be usable or not usable, but art. And the direction was art. So this '62 workshop is where it started. So Corning, at the 30th anniversary in '92, wanted a celebration piece. And I made it. And that's actually not the final one. The real one is at Corning. They bought it. And
We had the poster of it and.
that's right.
Yeah, it was beautiful.
And because I was going to make this special piece, and it was an honor to be invited to receive this Ray Cow commission, I thought I should go to school and learn how to engrave. Up to that point, I had done, just sort of on my own, kind of teaching myself a little bit about it. But I didn't have any of this kind of machinery. I didn't know any of the tricks. I didn't have any stones. All I had were just a few little burrs, diamond burrs. And I could make marks, but I couldn't really do serious cutting, beautiful cutting. So I went to school at Pilchuck and I studied with Jurgi Hartsaba. from Czech Republic. He's sort of the granddaddy of the glass engravers of the world. He died last year. Unfortunately, we've lost him, but he did a great job of spreading the gospel around the world about glass engraving before he died. So I took that class, I made that piece, gave it to Corning, and then I started thinking, I think I want to express more about this. I want to do more of this. I want to try more of this. And so then I bought the little lathe, the baby, from Germany, had it imported, and then, or Austria, I guess, I don't know. I bought it through a firm in Germany. I think they're made in Austria. And then I brought it here, started doing a little bit of engraving. So then literally got hooked on this whole idea of cutting and deep gouge marks in the glass. And so if we go through that door behind you.
Could I ask you just one thing? Don't little specks of glass come off of this? Why don't you wear a mask? Do you?
Sometimes, but it goes into, it's in a slurry.
No, but for your breathing.
It's in a slurry. The powder that comes off is a slurry. It's wet from the water.
So no powder.
It's
comes
not
So
out.
there's no dust. There's no dry dust that I could breathe.
Okay, good. I was really worried
Yeah.
about you. I recognize this.
Is the white painted in glass and then covered with glass?
Colored rod. You see it on a lot of my work. It's not gonna work. You have to know what goes behind.
Is that satin finish? Yeah.
It's just a touchy-feely, I mean,
And that's
Very
part of my
sensuous, yeah.
process.
it's very
of trying to
sensuous.
Yeah, so if you added up all the hours it took you to do that.
Yeah, oh, it's not
How
very
many,
much.
it's not very much?
No,
You
man, it was
did it in one
a,
sitting? No. I don't know.
no, that was couple.
Are you gonna do it in weeks?
Pardon?
Are you
I
doing
did
a
it,
demo?
I did it.
You did it already.
There's not much to see, you know, it's like watching clothes dry.
Well, yeah.
When I was making the Corning piece, one of the trustees of the Pilchuck School came by, said, man who knows about money. I mean, he knows how to. He said, how much did they pay you for that?
Well, then
He
you've
said,
got
well,
this
not
big
very much
bubble and all this
compared to
heat
the
on
number
it.
of hours. He said,
He
how many
started
hours?
pointing out that
I said, a lot. I don't
huge
even
gathers
keep track of it. So he said, basically, you're working for 20 cents an hour.
Yeah.
Then it's made up from this
So did you
side.
change, did you learn something from that?
No. About 10 years ago,
What it does with
where I worked with museum pieces, reproducing the pieces that were in museum collections, and the goal for the project was to learn how they were done. But I wanted to make sure that no one would think that I'm trying to make, yeah, or even worse, what's the,
Replicas.
We got it.
yeah, there's a real bad, there's a word that's
Forgeries.
forgeries. I didn't want them to look like forgeries, so I made two changes.
blowpipe that you use for this.
I changed the size from the original of all of these, and I changed the color.
Yeah.
That way, nobody could ever really think that I was trying to foster them off as a forgery.
Good point.
the Verona
So
piece
if
back
we're
there?
making a goblet, we have a
Clear?
really tiny light pipe, but for this you have to.
Veronese,
Yeah.
yeah.
When I was younger.
Except I added handles,
Yeah.
which
we were seeing how big
Lena
it
was
and we had a
furious
about a piece of pipe. We were taking
Why
it
did you
together.
ruin that?
Is this your wife?
No, this is Jan Swalwell, Rob's wife.
Hi, Jan. Mary Bacon. Thanks for having us here.
Yeah.
We really enjoyed it.
Fritz, is this
So
one?
all of these come out of museums. That's the inspiration for it. Yeah, and that's why they're sort of over there.
did you have to
They're not really all mine. You know, I didn't think them up. Whereas most of these things,
So did you
I
have to
thought them up.
experiment to find out the
That
technique
looks like
that
something
Oh,
you
yeah.
find in your
Yeah,
grandmother's
and then
cupboard.
you satisfied your
Really?
curiosity by
Exactly.
doing it. Okay.
I
Yeah,
love this one.
that's the piece de resistance here in,
Yeah.
in the shop. This is the one.
And so you've got all your techniques here too.
Yeah, exactly.
But it's-
I'm really showing off there.
Wow.
Now with cut glass, old cut glass, I was told that it should be kind of sharp.
Yeah, yeah.
Um,
By sharp, it should be like this,
You should be able to feel it.
or like the top.
Yeah.
But what about this? See that's
that's-
done the same technique, except
Well, this is
this
the new
is
version.
more like, you know, this is more like pressed glass because everything is round
Yeah, okay,
and smooth.
yeah.
So this is fire polished, and this is hand polished. And you cannot get sharp edges with fire polishing. Fire polishing means you put it back in the glory hole and reheat it, and the fire itself polishes it. But it also does something that you might not want, and that is that it rounds off all these sharp edges. You can't keep them sharp and get it hot. If it gets hot, the sharpness is gone. Here, all the sharpness that I wanted is still here. And here. That's the sharpness that I wanted. And that's just typical of cut glass, grandma's cut glass. But this one is different. This is a demo for the students. I do a lot of. This is a glass formula that I made using rare earth element, erbium oxide. Gives this beautiful pink.
Is this the only one that you, oh, there's.
No, this one is neodymium, that one's mine, this one is mine.
So what we're
This one is mine, this one's mine.
do you want to just catch these other folks up now?
We just did, we can't.
Yeah, thanks, Jan. This one was made before I really understood cutting glass. So this piece was made maybe 15 years ago. And it was impressed with steel tools to get these ridges. But because it was heated, the ridges got very soft. And after learning what I could achieve with cut glass, like this, and this, I thought, I'll just go back into this where it's not sharp enough, and I'll sharpen it by grinding. So the very first cuts are made with a very coarse grinding material, diamond or stone. It's like 80 grit sandpaper, and then you go from the 80 grit to like 200 or 400, and then finally to a polish. So none of this has been brought up to polish yet. It's all in the early stages. But so this piece is still in progress, very much in progress. But it's going to have a look similar to this, right here, eventually. Probably won't bring it all the way to full polish. I might, some places I might. This one I brought to full polish. So it does look like it's been in the furnace, but it wasn't. It was all done mechanically or by hand.
Is it almost like
And
a
the only
jeweler's
reason you know
rouge?
that is because it's so sharp. Question?
Is it almost like a jeweler's rouge with something so fine that it makes it shiny?
It's so fine it makes it shiny, and the material we use is cerium oxide. Jewelers use rouge, which is iron oxide.
I see.
And we use cerium oxide because it's better for glasses. It cuts the glass better, faster. But we could use, I guess we could use rouge. I've never tried it. It's so messy.
It is.
Oh, it's
It
terrible
really
messy.
gets all over you.
Yeah.
Washing it out.
And the cerium is not so, it also gets all over you, and it's also messy, but it's flesh colored.
If you don't know, I know.
On your clothes.
So you don't, at the end of the day, at least you're not, don't have black.
Yeah, Florida, Louisiana.
area. Keep just a little bit around and clean up.
I don't try to hide the fact that it's glass. I don't try to make glass look like it's ceramics or some painting or something. I try to make the glass have its own properties and emphasize those properties. And that liquid gooey look is part of it. Now, the newest work is this cut business. So I'm actually exploring what glass can do. You see, in my mind, there's a huge difference between this piece and this piece. This very symmetrical, very tight. It was a good place to start. But what I really want to express is more the fluid feeling of glass. So this one, when it was hot, was already symmetrical. So it didn't have a chance really to get gooey and wet looking and fluid looking. This one will be cut just like this. All this outside surface will eventually get cut. But because of the way it was fabricated hot, it'll have that loose, gooey, liquidy look to it. That's the same way this guy started. So all these ribs that you see here now, a little bit sharp, they were all rounded originally when I made the piece, when I made this one hot.
So that one's still in process now.
This one I haven't even started grinding yet. Oh well, it's not bad like that, but it's going to be a lot better.
It's gonna be more of a smaller version of.
Exactly, more like this.
Eventually.
Yeah. Yeah. Or a squat version of this.
Exactly,
Yeah.
yeah.
Yeah. So
Okay.
I wish I had one of these in the hot state, before I started cutting it, but I don't have one available. So I ask you to sort
course
of
you could make
imagine.
You could make it.
I know I could, but
Yeah, okay. Didn't Frank Lloyd Wright call that honesty of materials? Fluid, gooey?
well, for glass, I feel it is.
Well, yeah, it's honesty.
Yeah. I mean, I would not say that of stone. Stone's a very, very different material. Glass is wonderful. It's a liquid when it's hot, and it cools down without going through the physical transformation of going from a liquid, the normal transformation of going from a liquid to a solid. The glass is hard, but if you examine this piece of room temperature glass in an electron microscope, you'll see that the molecules and the atoms that are in this are randomly scattered like they would be in a liquid. Unlike if you looked at a piece of steel in an electron microscope, all of the molecules are lined up like soldiers, or band, I always say, like a marching band out on the football field. And that's the definition of a solid. That's the physicist's definition of a solid, is that it's a crystalline material with this perfectly symmetrical pattern. But when you look at glass, it's not a symmetrical pattern. There's no pattern at all. It's random. It's just like water would look, or like glass would look if it's hot. So this doesn't fit the normal three parts of the world, which we say is solid and liquid and gaseous. Glass really should be a fourth state of matter. And there are a few scientists that have titled it the vitreous state, and they've tried to define that as a separate fourth state of matter. But the classic physicists don't buy into it yet. But it's different. It has some of the properties of a solid and some of the properties of a liquid, even while it's hard like this. So that's something that I haven't yet figured out how to demonstrate that with the cutting. That business of liquids versus solids. But that's where my head is. That's what I'm trying to think of, ways to exhibit that.
Seems like the cutting almost contradicts that fluid state. And if in your mind you're trying to.
But I think I got it here.
Yes, you do. Yeah. That's a gorgeous.
And one of the reasons that this one has that look, that fluid look, and this one doesn't, and this one doesn't, is that this started looking gooey.
Got it here. too.
Lack of symmetry.
I don't think you can get much more
Or
fluid.
lack of more rigid symmetry, because with that other one, it looks like we did his math just fine, you know?
Distinguish them is high resistance to acids and low expansion rate. So labware, glass labware has been made for centuries before the invention of borosilicate. And those were all soda lines. Those were very difficult to make.
So it's really a time issue. This, is this borosilicate? This is.
Nothing. You think? But the thick to thin variation, what caused that? And if you look at what they were making, the glass blowers made windows by spinning out disc, a plate. And it was generally thicker at the center and thinner at the lip, generally. So when you get ready to put the piece of glass in, where are you going to put the thick part? Up? Probably not. Probably put it down. So we think now that that's the way they were originally laid up. The thickness and thinness came from the blowing process, not from the force of gravity over time. So I've been telling people that that's not true, and then I had an opportunity to go to Alfred, where there's a glass science, very famous glass science department, and I got to talk to one of the hot dogs there, one of the major physicists in the glass world. He's written the classic textbook that everybody uses. And I introduced myself and I said, I've been telling people that this story is not true, that glass doesn't move. Am I right? And he said, no, you're wrong. It does move. And I said, it does? Why did these goblets not change their shapes then? Whether they were laying on their side or they're standing on their lip or their foot, why didn't they change with time? He said, oh, well, you haven't waited long enough. He said, in 5 or 20 million years, they will change. But you cannot see it, you cannot measure it. But we know that there is movement there. We just know that it doesn't. But it's not, that's not why those cathedral windows were thick on the bottom.
How about the waviness of the glass?
The waviness comes from not being able to melt the glass hot enough and long enough to get all the material into solution. And so some of the material is, it's like chunky peanut butter. You know, if you grind it long enough, you get smooth. But if you stop early, you get chunky.
It's a process.
Okay, so that's what those striae are actually materials that didn't quite go into solution. They hadn't been stirred hard enough. A composition that Don Hansen developed that has the same expansion as the regular glass, but it's very stiff. This is my first cutting on that foot. This is all just engraving. That's just plastic. I did and play with copper enameling while it was still hot in the furnace, in the oven, I mean.
Yeah. And so when did you do the drawing on your hand?
Oh, when I made this piece in 92, 93. That took about a year and a half to finish it.
Fritz,
They say 93. I finished it in 93.
Fritz, you have a piece in the
And then this is one of those. I don't know which one it is. And then this one is one of them. I think it's that one right there. And that one I think is this one over here.